All right. For question 2, we want to know what proportion of students in the statistics class have vision correction. So we will use the variable vision bind. What's the point estimate P? Well, that's the sample proportion. So that's what we're going to do. Let's go get it. Here's how you do this analysis. Statistical analysis. All categorical variables are inherently discrete. So discrete variables. And then I go to one sample proportion test. You'll learn why it's a test in Unit 8. But it's the same math. So we're going to click on that option. Choose vision bind. And you have to turn on the chi-square test, turn off the exact test, and turn off the continuity correction. Now, alternative hypothesis doesn't matter right now. And null hypothesis doesn't matter right now. All we want is the confidence interval, so I set the confidence level. I said we wanted, well, it doesn't matter, but I've read the next question. We're going to want a 95% confidence interval. And then I click OK. And it gives me the sample estimate right here. Sample estimate is 0.4897 other stuff. But I said I want it rounded to 3 places, so now it's too many places. So 4.897, that means that this is going to be 4.90. And that's what it is. That's for this data set, that's the answer to that. Next question. Find the critical Z for the 95% confidence interval. Well, you probably have this memorized. The critical Z for a 95% confidence interval is 1.96. But if you forget that, or if you need a different one, you use the function equals norm_inv. I've opened up Excel for this, or my spreadsheet, which is LibreOffice. Norm_inv 1 minus alpha over 2. So for 95% confidence, alpha is 0.05 over 2. 1 minus alpha over 2, 0, 1. Close it off, hit enter, and of course it is 1.96 as advertised. Round to 2 places, 1.96, done. Next, compute the 95% CI, and that's done for you automatically with R. When we chose to run the confidence interval, that's what we got. Oh, I'm done with this, put that away. So let's go look at the confidence interval. Here it is, 0.35 something. That's the lower limit. And the upper limit is 0.62 something. It just gives it to you right there. Right here where it says 95% confidence interval. That's the 95% confidence interval. Now I want to round it to 3 places, so that's going to be 0.356 and 0.625. And click Submit, and that's that. Next, what does this tell us about the population? Well, we are pretty sure that the population mean is somewhere between those two numbers, between 0.356 and 0.625. We're 95% confident that the population proportion of people who have vision correction is somewhere between there. Is it reasonable to conclude that half the population? Well, half is inside this interval, so yes, that is reasonable. Okay. Next, if we want to design a margin of error E to be plus or minus 0.1, how large would it have to be? So I'm going to use my parameter estimate, that is p hat of 0.490 in my estimation here. That's how we do that. So I'm just going to go ahead and answer this just for fun, so I get another green. Okay, coming in here. Here's how you estimate sample size using RcmdRPlugin.EZR. You go to Statistical Analysis, Calculate Sample Size. The first option is what we want right now. Calculate sample size from proportion and confidence interval. Click on it. Give it the proportion that you're starting as your estimate, which is 0.490 from the data. How wide do I want the interval? Well, I said plus or minus 0.1. That means the width is going to be 0.2. 0.1 above and 0.1 below. That's what it means to be above and below. So click OK. And it gives me this awesome graph that shows me the trade-off of different sample sizes. And then I go look here at my required sample size. It's going to be 96. That's the answer to that question, 96. Submit.